Squared theta is cosecant squared theta, right? That's what it is. We could do that, or we could do that. Right? I think this is better, though, right, to do this. But I'm going to do it your way, because I just want to show you we can get to the same answer. So I've been asked to maybe break this cotangent down as cosine squared theta over sine squared theta. So I'm intentionally taking the longer path here. Intentionally. What now? Does anyone see what I'm going to do or no? No?
Because I was looking at that top one, trying to see how we could get to that. So
What, to this?
no, on the other way.
Over here?
Yeah, I was kind of looking back to the sine square.
Yeah, we're going to get there.
So maybe if we were to divide both sides.
You don't have both sides. There's no sides here, right? There's no equation, so you just have to work with this. Who sees it? Distribute. There you go. Multiply here and here. So what happens when you do sine squared theta times 1? Sine squared theta. What happens plus, right? Plus, when you do this one times this one, what happens? You have a sine squared on top and a sine squared on the bottom, right? And they'll cancel, and what will you be left with? Cosine squared theta. So that's where you are. But what's this? 1. Because that's Pythagorean identity, the first one. So this equals what? So that equals that equals that equals 1, which is the right-hand side, and we're done. But really, in hindsight, I really do like us having done this instead. The first one turns into sine squared theta. The second one turns into cosecant squared theta. And then I could rewrite that as sine squared theta times 1 over sine squared theta, because that's what cosecant squared theta is. And then they just cancel right away, and I get 1. I like that way. To me, that's cleaner. But I showed you all this last time. We're trying to get from point A to point B. Right? And as long as you don't break any algebra, you're going to be on a path. And your path might be different than someone else's. Might be that one, right? We talked about that. That might be, get your shit together, right? Right? Come on. And then eventually. So if you ever break the algebra, though, right? If you ever break a rule, that's it. It's over. Now, if you start seeing yourself wandering over here, right? Sometimes it's best just start over. Just start the whole problem over. Look at it from a different perspective. The worst, these problems are the worst when you cannot find your way to the answer. When you're just stuck on a road, you don't think you've done anything wrong, and you just can't figure out how to get there. Because you know the answer, right? It's not hiding from you. The answer is the other side of the equation. All right, so far, how about this? This one looks terrible. Tangent squared theta, cosine squared theta, plus cotangent squared theta, sine squared theta, equals 1. Start with the left-hand side. All right, we're moving on to, we're going to go to this table over here. Either one of you, your team, you're going to sink or swim together. Just tell me to do something, I'll do it.
Both tangent and cotangent can be put into like tangent.
They're reciprocal, like written in terms of sine and cosine?
Yes.
Okay, yeah. So if you ever get stuck on something and you have like tangents and cotangents or secants and cosecants, you can just try to get everything in terms of sine and cosine. So you want me to rewrite this how?
Sine over cosine.
Sine over cosine. So I'm starting with the left-hand side, right? Sine, that's sine squared theta over cosine squared theta, right? And then I'm multiplying, right? Multiplying that times this, cosine squared theta. Plus now cotangent is which one over which one? Cosine squared theta over sine squared theta times sine squared theta. Don't write equals 1. Remember, we're starting with the left-hand side. We're going to try and turn it into a 1. Man, you just like took like the direct line there, right? Do y'all see it? What goes away? Cos gone, sine squared gone. And now you're just left with sine squared theta plus cosine squared theta, right? Which is 1. Do these seem hard or no? Are you like waiting? Like, when does this get hard? Okay, it's coming. It's coming. This is an interesting one. I'll do it over here. Okay, how about cosecant to the 4th theta minus cosecant squared theta equals cotangent to the 4th theta plus cotangent squared theta. All right, let me mention something first. The Pythagorean identities over here, you cannot change these numbers to whatever you want. So you can't say, oh, this, if you change that to a 4 and a 4, then the identity is still the same. No. It only works with squared squared. And it comes from the idea that the Pythagorean identity came from a right triangle, and it was a squared plus b squared is c squared. That's where it came from. The Pythagorean equation says a squared plus b squared is c squared. It doesn't say a to the 4th plus b to the 4th is c to the 4th. So we can't just change these arbitrarily on our own, all right? Just so you know, can't do that. The other thing you'll notice about this problem is that the left-hand side and right-hand side look equally crappy, right? Like there's not an obvious which side is worse than the other, right? So you really have a choice here. You know, you can pick, all right? So which side do you want to start with? I don't care. You want to go to the left again? Okay. Whatever you do, do not start manipulating that equation. Don't start moving things around. Do not do that. You're asked to verify this is true, so you have to start with one side. Have I said that enough or no? Okay. Cosecant to the 4th theta minus cosecant squared theta. All right. You're up. See, I don't know where all your friends are. You weren't here? Oh, yeah, but tell me to do something. Just look at this. I don't care. How about if I ask you to factor? Do they both have something in common? What do they both have? Cosecant squared, right? They both have a cosecant squared. Could you factor out a cosecant squared here? Could you? Okay, let me do that. Pull out a cosecant squared. So I would need a cosecant to the 4th, so I'd have to have a cosecant squared there. Minus there, I'd have to have a 1. Follow? Just pulling cosecant. Now, why did I do that? I'm not quite sure. It just seemed like I wanted to do that. Just seemed like a legal move, right? But better, this might be a Pythagorean identity. Is it? I erased them.
Yes.
It was, the other one was 1 plus cotangent squared, I'll put x here so it matches these, equals cosecant squared x, right? That was the third one. Does this thing, can I do this, make this turn into a cosecant squared x minus 1? I can, right? I'd have to move the 1 to the other side. And then that means this would become what? Cotangent squared, right? Cosecant squared theta times cotangent squared theta. Is that the right-hand side? No. Look where you're trying to get to. Look where you're trying to get to. Okay, back table.
Change cosecant of theta squared to
You want to change this one to what? Cotangent squared theta plus 1. So you're using this identity again. Cosecant squared theta is going to be 1 plus cotangent squared theta. You're going to use that for that piece I circled. So this becomes 1 plus cotangent squared theta. That's that. And then here, cotangent squared theta. Why'd you do that? Okay, but you could have done a lot of different things. Why didn't you turn this into like 1 over sine squared? You could have done that, right? Could have turned this into 1 over sine squared. Could have turned this into cosine squared over sine squared. There's a lot of things we could have done, right? So why turn this into this? Does anyone see why? Yeah, look what we're trying to get to, right? Cotangents. Do y'all see it? Do y'all see it right there? Right here, distribute that cotangent squared through. Multiply this to this, multiply this to this. If you do that, you get the right-hand side. And we're done. Is that the only way to do it? No. So pulling out a cosecant squared theta in the beginning helped us use this piece for a Pythagorean identity. And then we used the Pythagorean identity on this piece again, and that gave us all cotangents, and we multiply together, we get the right-hand side. May I erase? Don't need? What's your feeling so far? Is this not enjoyable? And it's okay. I mean, cosecant u minus cotangent u equals sine u over 1 plus cosine u. Right off the bat, you should be thinking, crap, I can't use the Pythagorean identities, right? Because all of these require squared stuff, right? None of this stuff is squared. So where shall we begin? Left-hand side or right-hand side? What do you want? Left? All right, where are we at? Who wants to give me the first step here? Left-hand side, cosecant u minus cotangent u. You want to go back? Yeah, you've already done it, but go ahead.
Maybe you could break down the cosecant and cotangent to 1 over sine, and then, what is it, cosine over sine?
So 1 over sine, cosine over sine. Yes? All right, that's fine. 1 over sine u minus cosine u over sine u, right? Y'all buy that? Okay. Who wants to give me a next step? Go ahead. You can put them together. They have the same denominator, don't they? Yeah, we can do that. These have the same denominator. We can put them together into a single fraction. So we could write 1 minus cosine u, 1 minus cosine u over sine u. All right, that's fair. Remember what we're trying to get, right? This is what we're trying to get to? We look pretty close, don't we? Or don't? Nah, not. We can't just flip that over, right? And it's off by a sign, you see that? What the heck, right? How are we going to get from this to this, right? Seems like there's no way we can get there, right? Yes. change this one to sine u over sine u. You could do that. Yeah? Do you want me to do that? All right. I've got to ask you why you want me to do that now, because this is all over what? Sine u? Like that? We could do that, right? That's not legal. I mean, that's not legal. That's not illegal, right? We are trying to get from A to B right now, and we are on a path. Yes? Have not broken any algebra rules. I'm not quite sure what the motivation is. I'm only asking this because we have to have this discussion, because everybody has to have this discussion with themselves when they're doing these problems. Why am I doing what I'm about to do? Right? So did you have any sort of motivation for that? Like what you're trying to achieve with it? You're trying to get, what do you mean, down here? You're trying to get that to cancel? Because you don't see it here. Is that what you're getting at? Okay, so you're seeing that there's no signs on the bottom. Here we have a sign on the bottom, right? Here we don't have any signs on the bottom. So you're trying to do something to make that sign cancel. I like that thinking. Not quite sure that's going to get us there, but the thinking is correct. I have
more of a question.
Yeah, question, yes.
Why were we able to just turn the 1 into sine u over sine u? Like in any situation, could we turn a 1 like this into, could we only turn it into sine u over sine u?
Oh, no.
Or could we do other things?
1 can be,
Situation?
Anything over itself, right? I could have put cotangent u over cotangent u. I could have done, I don't know, my daddy over my daddy. It doesn't matter what it is, right? It's still 1, you know what I mean? Yeah. Anything can be rewritten that way. Okay. That's why I was asking, why did you use sine u over sine u? And I think the goal was to see if we can get the sine u to go away somehow, right? I like this approach. Let's do this. At this point right here, I'm going to put an arrow. That's one path we could take, right? That's one path we could take, and that would be that path. There's other paths, right? So I'm open to someone else's path. I'm not saying that your path is wrong here, okay? I just want to see if there's another path. Hang tight. Anyone here in the middle?
Isn't there an algebraic rule where like 1 minus cosine u over sine u like it equals a reciprocal somehow? Is that what we're trying to figure out?
Well, what we're being told is that as long as you believe that what we first did is true, right? Does everyone agree with this and this? Right? We didn't make a mistake here, right? This is correct? And we put them together. We can do that, right? Same denominator? And so that's this. What we're basically being told here is that that is somehow this. And we just have to show why it is. Right? We're trying to show that this becomes this somehow. We're trusting that it's true because they wouldn't have asked us to show it if it wasn't true. This is this, but how? Show me. Prove it to me. Right?
And you can't just flip it and change the sign?
Can't flip it and change the sign, no. Think about if you had a fraction, right? 1/4. Can you just flip it and change the sign and it's the same thing? No, right? You can't just do that, right? So same thing here. All right. You all ready? I'm going to give you a correct path, all right? And here's my thinking. My thinking is almost what you were saying. I don't want a sign here, right? It's almost that thinking that here I don't have a sign, right? Here I do. My thinking is a little different. In this denominator, I have a 1 plus cosine u, right? Over here, I don't have a 1 plus cosine u. So I'm going to make it appear. Slightly different thinking, yes? I'm going to take this equation, 1 minus cosine u over sine u, and I'm going to force a 1 plus cosine u on the bottom. But the only way I can do that is if I multiply the top and bottom by the thing I'm trying to make happen. See, I'm trying to make this appear, right? I'm trying to make that appear. So here it is. I made it appear. There's a 1, right? That doesn't seem very fair, but I can do that, right? Yes or no? Come on.
Yeah, you're multiplying.
Yeah, now I'm multiplying, right? Okay, so hang tight. Watch what happens now. in the numerator, I would have to multiply those together, wouldn't I? Which means I have to FOIL them. And that's a difference of squares, isn't it? So what would happen? 1 times 1, that's 1, right? What about the middle terms? What will happen to the middle terms? They'll go away, won't they? So all I have is the outer terms. This times this. What's that? Minus cosine squared theta, right? Or sorry, u, right? Does everyone agree that's the numerator? But what's that? That's sine squared u, isn't it? Now, let's just see what's on the bottom still. I had the sine u down here, right? And then I'm supposed to multiply this, but I'm not going to actually multiply it. I'm not going to actually multiply these two together. I'm not going to distribute the sine through because I'm trying to get this sine to go away. Why am I trying to get the sine to go away? Because where I'm trying to get to doesn't have a sign down here, right? It has a sign up there. Do y'all see it now? Do y'all see that the top's going to be sine squared? And do you see that one of the signs are going to cancel? Pythagorean identity on top. Sine squared u over sine u times 1 plus cosine u and then do you see one of the signs cancels? This sign cancels with one of those. And what are you left with now? The right-hand side. Tricky, huh? That was tricky? Would you like me to go down this path or no? I mean, no? Did you try a little bit? No?
I could just tell by doing it in my head, it'll just go right back to A.
It'll go back to where we started?
Yeah. Like
Yeah.
you did the copy dot flip.
I don't know how we would. Yeah, if you like did this and brought it up as a 1 over sine u and then distributed through. Yeah, we'd probably just wind it where we were. Yeah, back to, yes?
So where did the 1 plus cosine u over 1 plus cosine u come from again?
Right here.
Oh, just make it up.
Yeah. Well, no, but I didn't make it up like just out of nowhere. What I did was I said, here's where I was, right? And I said, shit, this sucks because I have in the bottom sine u and over here I have a 1 plus cosine u. So what I'm going to do is I'm going to say, hey, what would happen if I forced it down here? Which means I have to multiply by 1, right? That's a 1, anything over itself. So I put the thing I wanted to appear on the bottom, I put it there and I put it on top. But while I wrote that down, I realized, oh my gosh, this is going to be a difference of squares. Or sorry, this is going to be, it's going to FOIL out and become a difference of squares. And that's going to be the Pythagorean, and that's going to turn into sine squared, and then the sine's going to cancel. The more of this you can see out in front, the easier it becomes. But it, right now, a lot of you in here can only see an inch in front of you. You can't see 3 steps ahead yet. It takes a lot of time to get comfortable to the point where you see it, you see it all kind of coming together. But now you know that if you're in a position where you're trying to get something turned into this and you can't see a direct way there, you can just start inserting things that you need and see what happens. Question?
I was just going to ask, when you went from 1 minus cosine squared u to sine squared u, I know
Yes.
it's an identity. Do you mind writing it really quickly?
It's right there. It's this. It's the top one, right? Just move that over. Now, if you want, I can do this. Why lock all the wheels? Not necessary. What I can do is this. I can say, if you have sine squared u, sine squared theta plus cosine squared theta equals 1, that's the main one, right? If you solve this for sine squared, it becomes 1 minus cosine squared theta. And you solve it for cosine squared, this is so sloppy, I'm sorry, 1 minus sine squared theta. Those are the 3 different versions of the first Pythagorean identity. The first one is the way we see it in a formula sheet. The second one is solved for sine squared. The third one solved for cosine squared. Understand? You could do that for the other 2 Pythagorean identities as well. All right, let's do some more. You need to see me do some of these to start to understand what some of the tricks are that you can try. That was a trick, right? That was not natural what we just did. let's see here. What the hell? Okay. 9 secant squared theta minus 5 tangent squared theta equals 5 plus 4 secant squared theta. Did I tell y'all last time that this is one of the least favorite sections of most pre-cal students? Yeah, okay. But it is probably the most, I'm not going to say it's the most important section. You're not going to be proving identities in calculus, but it's the level of thinking that's required here. I mean, I told y'all that in my Cal 1 classes, I tell them, you need to be able to know your unit circle. You need to know how to solve trig equations, right? But at the end of the day, the reason why pre-cal is required before Cal 1 is because you have to get to a certain like mathematical maturity where you're just at a certain place where you're ready to take in the Cal 1 concepts, right? It's a maturity thing, a mathematical maturity. And so this type of problem really tests or it helps you become mathematically mature. That makes any sense, right? We're going through puberty, math puberty right now, all right? Puberty kind of sucks sometimes, right? Here we go. Left-hand side. What do you want me to do? Pardon? Do left? Okay, start with the left-hand side. I'll do that. Left-hand side, 9. Now this, when you make this first move, okay, I want you to think about this first move. It shouldn't just be some random shot in the dark here. Look at what you're trying to get to. What seems the most natural thing? You got something?
To change the tangents into your secant squared theta.
Yeah, I mean, the right-hand side has secants, right? Secants, and that's it. Your left-hand side has secants and tangents. So why don't we get rid of the tangents, get them in terms of secants? Can we do that? We can, right? Anywhere we see a tangent squared, we can replace it with what? Careful.
Secant squared minus 1.
Secant squared minus 1, right? So if we want to replace tangent squared, we move the 1 to the other side. So I can write this as 9 secant squared theta minus, now this 5 here is in front, right? It's 5 of these. And that's going to turn into 2 things, right? Secant squared theta minus 1. So this needs to be in parentheses, secant squared theta minus 1. Y'all see if you can distribute the 5 through, right? That would be next. Nope. Stupid. All right, those are the 6 different things that you could have, I guess, if you want to look at it that way. With the Pythagorean identities, you've got these, right? You've got these. And then those are the other 2 solved for, first one on the left board there, that's solved for secant squared. The second one below, it's solved for tangent squared. And then on the other board, it's cosecant squared. And the other one solved for cotangent squared. So we got this. Distribute 5. 9 secant squared thetas. Negative 5, so minus 5 secant squared theta. And then minus 5 times minus 1 is plus 5. And I think that's the right-hand side, isn't it? Is that not the right-hand side?
It is.
It is, right? We have 9 of these, right? 9 of these. We're taking away 5 of those. That's going to give you 4 of them. And then plus 5, which is the right-hand side. That one actually wasn't as bad as the previous one, was it? All right. Do, 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 do. 1 minus the fraction sine squared theta over 1 minus cosine theta equals negative cosine theta. We're trying to get from, I think the left-hand side, right? We should start there. Trying to get that to turn into negative cosine theta. Ooh. Yikes. So I see it a couple of different ways here. So I'm afraid to see you like go on this path, like, you know. But you got to make a move, right? You got to take a swing here. You got to do something. Go ahead. Yeah, okay, that seems natural, right? Change the sine squared to 1 minus cosine squared. That seems reasonable because we have cosines over there, may as well. So that would become 1 minus, what would this become?
Cosine squared theta.
1 minus cosine squared theta, right? 1 minus cosine squared theta. On top and on the bottom, 1 minus cosine theta, right? I'm starting with the left-hand side here. Hey, wait a minute, does that? No, you can't do that. Can't do that. What can you do? This is the tricky part. See if anyone sees it. Wait, do what? This one? Yeah, you could do fraction. Do you want me to leave it as a 1 over 1? 1 over 1. Oh, okay, I see what you're saying. You can't put these together because they don't have the same denominators. I think what you're trying to do is like this minus that. Is that what you were doing? No? No? You can't put these two fractions together right now because they don't have the same denominators. So you'd have to get a common denominator if you wanted to do that. Right? So I'm going to leave it as a 1 for now. Yes?